Well, by the time we're done with this section, section 10, we will have been sketching and interpreting graphs. But in order to sketch them, to sketch a graph, what we're going to have to do is learn to take an equation out of a story problem. So in number one, a car rental business rents cars for $20 a day plus 15 cents per mile. What we're wanting to do is to write a linear equation in slope-intercept form that models this situation. All right, we're going to take this story problem and write a linear equation in slope-intercept form. Great. How do we do that? Well, there's first of all, there's a few things that you would want to do here in terms of looking for key words in your problem. So look for anytime you're writing, what are we doing? We're writing an equation, slope-intercept form. We're given a story problem, right? Look for certain words like the word per or each, rate, speed. All of these things have one thing in common. They stand for the slope. And isn't that the first thing you're going to be finding when you're writing an equation in slope-intercept form? So we need to find the slope first. And keep in mind that our end product here, our final answer, is going to be y equals blank x plus blank. We've just got to fill these two blanks, right? All right, so what we need to do is find the word per, each, rate, speed. Do we have that, any of those words in this problem? Yeah, right here. There's the word per, and the number that's associated with that word is going to be the slope. So our slope has to do with the 15 here, right? But it's not going to be 15. Why? Well, because I'm talking about $20 here, and I'm talking about 15 cents here. So what we need to do is convert the 15 cents into dollars, and that makes it 0.15. And this is one of the few exceptions to writing your slope in fraction form. When we're talking dollars and cents, obviously you can keep it in decimal form. So our starting point in this problem is $20. Every day we're being charged $20, so that's the starting point. Even if you don't drive it at all, it's still going to cost you $20. That's the starting point, so that's the y-intercept. Our slope, like we were saying, is the 0.15. So y is equal to 0.15x plus 20. In number two, a dog weighs 20 pounds, is on a special diet to lose 2 pounds each month. Well, find that each there. That's the slope. What's the slope? 2. But it's not going to be exactly 2, though, is it? Because we're on a special diet to lose 2 pounds each month. So if we were wanting to gain 2 pounds, now remember, what's the starting point? The dog weighs 20 pounds right now, right? If we were wanting to gain weight, we would add 2 pounds each month, but now we're wanting to lose 2 pounds each month, so what's going to be subtracted? So our slope is -2. The y-intercept is 20. It's the other number. So you're going to write your equation. Y is equal to -2x plus 20. Now, and think about this. You know it's going to something's going to have to be negative here, right? So would you do, y equals 2x minus 20? Well, that would mean that the dog is weighing in at -20 pounds. So that's not going to make sense. So we don't want the minus sign there. The minus goes with the 2 because we're losing the 2 pounds per month. So it's -2x plus 20. Let's look at number 3. A video store charges $8 for a rental card plus $2 per rental. See, what that per means is that we're going to be multiplying. Per means we're multiplying. 2 times every rental. $2 per rental means $2 times every rental. So that's our slope. So our slope being 2, a lot of 2's here, right? 2's and 20's, it seems like. All right, $2 per rental. We're going to have y equals blank x plus blank. $2 per rental, 2 times every rental. We're starting at $8, so y is equal to 2x plus 8. A plane flies at 3,000 feet and is descending at a rate of 400 feet each minute. Descending at a rate each. There's 2 words that we're looking for. 400. Descending. If we were ascending, that would be positive, would be going up. That's ascending, positive 400. Descending means we're going down in terms of our altitude. So the slope is what? Negative 400. Where are we starting at? 3,000. So that's the y-intercept. So y equals negative 400x plus 3,000. And that's how you write equations from story problems. Find the slope, plug it into your format, y equals mx plus b. The other number, I can tell you right now, is going to be the y-intercept, and you're done. All right, so how do we sketch graphs? Well, let's look at this particular problem. Now, I pulled these numbers off the internet. They're approximate. They're not exact, so don't quote me verbatim on this. But in 2011, Apple had about $9.4 billion in revenue from iTunes. Apple earned about $3.3 billion in each of the following years. So let's write an equation to find the revenue, R, as related to the number of years, T. And to do that, we're going to look for the word each. There it is, right? So 3.3 must be the slope. We're going to be taking it times what? X. But it's not going to be X this time. We're taking 3.3 times the number of years, T. We're going to use T instead of X here. So that must mean that R is the Y value, T is the X value. So R is equal to 3.3. We're not going to write out all those zeros. We're just going to use 3.3 times the number of years, T. What's the starting point? Plus 9.4. So there's your equation in slope-intercept form. How do we graph it? Well, I'm in doing years, class. What you don't do is you don't use the year number. Like we wouldn't use 2011 here. What we're going to use is year 0 because that's our starting point. Now I'm going to skip a few lines and go here. That'll be year 1. Skip a few more, that'll be year 2. Skip a few 3 more, that'll be year 3. And skip a few more, that'll be year 4. So this is if this is 2011, 1 is 2012, 2 is 2013, 2014, and we're ending with actually at 2015 here. Now, and by the way, time is always across the bottom axis. In this case, revenue, money, will be on the y-axis. And remember, this is in billions of dollars. Your graph has to reflect that we're talking about billions here, not just $9.4, not $9.40. It's 9.4 billion. What I'm going to do is I'm going to show a break in the action here by putting this jagged line. That means we're skipping from 0 to, let's say, to 9 billion. And the next line I'm going to go to 10 billion and 11 and 12, 13, 14, 15, 16, 17, 18, and finally topping out at $19 billion. And now we're going to graph this. Well, if T is 0, which means 2011, what's our starting point? 9.4. So about halfway up on the 0 mark, go to 9.4. in year one, 2012, but year one, we're going to take 3.3 times 1 plus 9.4. We'll get 12.7. So at year one, we're going to be at about 12.7. So a little bit more than halfway between 12 and 13. And year two would be 2 times 3.3 plus 9.4, and we're going to get up to, that's right, 16. So at 1, we're going to be at 16. Or at 2, sorry, we're going to be at 16. At 3, we're going to be at 3.3 more, so it's going to be about here. And you can draw your line accordingly. Look at that. They all line up. Well, what would their projected revenue be in 2014? So what we would do is, now 2014 would be year 3, right? So that would go up to there, and we would come over to here. And so that looks like about 19 point something, right? A little bit more than $19 billion. Well, how we could find that is by taking 2014, and what year is that down here? Year 3. And let's plug that into our formula and see what would happen. Well, 3.3 plus 3.3 times 3 is 9.9 plus 9.4 would be $19.3 billion. And isn't that about what we came up to right there? Is a little bit more than 19. So you can always plug the number of years into your formula and come up with your answer. Well, in the next problem, we have the Mooch family driving cross-country on vacation. They drive 330 miles in 5.5 hours. Well, we're going to be using the formula distance equal to rate times time to help us out with this. So if they drive 330 miles in 5.5 hours, that's the distance is 330. That's equal to the rate. That's what we're looking for. How fast are they going in that 5.5 hours? When you take 330 and divide it by 5.5, what do you get? Well, you get R is equal to 60. So they're doing about 60. They're doing 60 miles an hour. But that's not the equation, though. The equation is D is equal to 60t. Remember, we want slope-intercept form here, right? And this is your y value. The t is your x value. So D is equal to 60t. This is the equation you're looking for. Now we want to graph this equation. And to speed things up a little bit, I went ahead and labeled my graph here. I've got the hours across the bottom. You always want time when it's available. You always want time across the x-axis, which means we're going to put miles on the y-axis, right? So I counted these off 0 through 12 hours and then 0 through 600 miles. And to graph this, well, if we drive 0 hours, we're going to be going 0 miles. And if we go for 1 hour, we'll be going to 60 miles. And at 2 hours is 120. And well, at 10 hours would be 600, which is the answer to our next question, right? But if I were to graph that, look, see how that they all line up nice and neat. And if we had gone 6 hours, that would be 360. Look at that, right there. We're right on this. So how long would it take to drive the 600 miles? You can do it a couple of different ways here. You can take the 600 over to the graph and then take it down to the x-axis, and you can see it's at 10 hours. Or you can take 600 miles and put that in for the distance. So 600 is equal to 60 times t, and obviously divide both sides by 60, and you get t is equal to 10 hours. Now the cost of candy is $4.50 a pound. So the cost, C, is equal to $4.50 per times the number of pounds. So there's your equation in slope-intercept form. C is equal to 450p. graph this equation? Well, again, I went ahead and took the liberty of putting our pounds across the bottom here, 1, 2, and 3, like so. Cost would be on the y-axis. 0 pounds would be $0, right? 1 pound is $4.50. So if this is 4, here's 5. $4.50 would be right about here. 2 would be $9. That'll be here. And I can graph that. I can draw a line through those points. And this represents the cost of pounds of candy here. So 3 pounds would be what? Off the chart, right? But it'd be about up here. So what would 3 pounds be? $13.50, right? And that would be about right, wouldn't it? Whoops. There we go. Yeah, it looks at about 350. But actually, it's asking for 3/4. And here's the reason why I skipped 4 lines for every pound, because 3/4, wouldn't that be right about there? So if we take that up and then take it over, how much are we talking here? Somewhere between $3 and $4, right? Well, let's find out exactly what it is. So the cost is $4.50 times every pound. Well, let's take $4.50 times 3/4. And it says in my calculator 3.375. Well, what would that be in dollars and cents? We're talking 3.38 rounded off. Okay? So that's how you draw graphs from a story problem. The next thing we're going to be doing is we're going to be interpreting graphs. Looking at a graph, trying to decide what it's telling us. The graph below depicts Kelly riding her bike, leaving her house at noon. Well, so here's noon. She's home here. And then she does this. Well, what does that mean? At 12:15, she's 2 miles from home. Then for the next 15 minutes, does the distance, because we're talking about distance here, does the distance change from 12:15 to 12:30? No, it doesn't. So what happens here? Well, she is stopped, probably to talk to somebody. Maybe she had a flat tire and had to air it up or something like that, whatever, right? But anyway, the point is that from 12:15 to 12:30, the distance did not change. That means she didn't move. During which interval, 15-minute interval, did she bike the fastest? Well, it wouldn't be that 15 minutes because she stopped, right? Well, let's see now. She rode 2 miles in 15 minutes there. That goes from A, let's call that A and B and C, D and E, right? From B to C, she stopped. From C to D. Now, look, here's another 15 minutes. Now she went 1, 2, 3 miles in 15 minutes. And then she went from 5 back. Now, what is she doing here? She's going back home, right? So from D to, because she started out at home, she rode back to home. The distance, because we're talking about the distance from home. Well, she's back to 0 here. That means she rode back home. So that means she rode 5 miles in 15 minutes. So which 15-minute interval did she bike the fastest? From D to E, 12:45 to 1 o'clock. How many miles did she bike in total? Well, she went 5 miles out and 5 miles back, so that would be 10 miles total. In the next problem, Zach is walking around his backyard. The graph below describes how he was walking. Now, and again, We have to compare distance to the number of seconds. This is distance here. Describe what's happening in the graph below with respect to time and distance. Again, I'm going to label, to make it easier to talk about these, I'm going to label these points A, B, C, D, and E. Describe what's happening in the graph with respect to time and distance. From A to B, what's going on? Well, it looks like he walked 100 yards, 100 meters, sorry, in 50 seconds. And yes, it's spelled correctly. Some countries will spell M-E-T-R-E-S instead of M-E-T-E-R-S. So depending on what country you're in, this is spelled correctly. B to C. What's going on here? Well, which direction is he going? What's he actually doing here? He's walking back toward the house, and he walks from 100 yards, 100 meters out to 40 meters out. That's 60 meters. That's what he's ended up walking here in how many seconds? Well, from 50 to 70, that's 20 seconds. From C to D, he's walked how far? Well, this is 20, 40, 60, 80, 100, 110. 20, 40, 60, 80, 100, 120, 140, thank you. 140 meters in how many seconds? Well, it goes from 70 to 100, so that's 30 seconds. And then from D to E, what's he doing? Is the distance changed? No. From D to E, he's hasn't changed, so he's stopped here. And that's how I would describe this particular graph. But on the next page, now we're talking about speed versus time. So let's, again, A, B, C, D, E, F, G, H, a lot of points here, right? Describe what happens between 13 minutes and 20 minutes. Now, 13 minutes, right about there, 20 minutes. So we're talking about D to E, right? Now, does that mean that we have stopped here? No, because what are we talking about? We're comparing speed. And something's not changing here. What's not changing? The speed's not changing. So what does that mean? It's running at 7 miles per hour. Describe the graph above with respect to time and speed. Well, again, from A to B, we're increasing to 5 miles per hour. We're getting on the treadmill and immediately go up to 5 miles per hour. So increase to 5 miles per hour. From B to C, we maintain 5 miles an hour, running at 5 miles an hour. And then C to D, we increase to 7 miles per hour. D to E, we were talking about how we're maintaining the 7 miles an hour. From E to F, we're slowing down to 4 miles an hour. F to G, we're running at 4 miles an hour. And G to H, what are we doing? We're slowing to a stop. This is where we're stopped. We're stopped here and here, which is different than the other graphs, right? Because the other graphs we're talking about distance. Again, here we're talking about speed. So that'll do it for this set of notes. The last problem we'll do in class. And good luck on interpreting your graphs from here on out. We'll talk more in class when I see you. Talk to you then. Bye. Bye.